So this is the 2014 Leaving Cert Ordinary Level Paper 1 and we're looking at question number 8. Part A says the length of the side of a square sheet of cardboard is 12 centimeters. Find the area of the sheet. Okay, well if it's a square, the area is length by width, which in our case would be 12 by 12. So that's 144. And it's centimeters squared if it's area. Okay, part B. The diagram below shows a square sheet of cardboard of side length 12 centimeters. So here's a square sheet of cardboard, from which 4 small squares, each of side length h, have been removed. So the 4 corners there have been removed. They're little squares of length h, some variable we don't know. The sheet can be folded to form an open rectangular box of height h. So you can imagine folding these sides up, creating a box with no top, and the height of the box would be h, it would be h deep. Okay, it says write the length and the width of the box in terms of h. Okay, well the length of this box, if you fold it up, we could call this the length here. And then you could call this distance here would be the width. Or the other way around, it doesn't matter. They're the same anyway, because it's a square box. So what is that length? Well, we know that this little bit here is h, and this bit here is h, these distances here. So those little bits are h, and the whole thing is 12, the whole width. So the bit in the middle then would be the full width, 12, or the full length, 12, subtract this h and that h. So in other words, it would be the 12 minus h minus h. In other words, 12 minus 2 h's, whatever they are. We don't know what they are, but we're allowed to give our answer in terms of h anyway. And the width of the box would be the same, going the other way, because you've got 12 this way, and again h. So it's 12 minus 2h for the length and the width of the box. Part C says show that the volume of the box in terms of h is 4h cubed minus 4h squared plus 144h. Okay, well the volume of a box, the volume of a cuboidal box, would be length by width by height. So in our case, the length and the width are 12 minus 2h, as we just worked out. So it's 12 minus 2h for the length, times the width, which again is 12 minus 2h. So that's the length, the width, and the height is just h, small h, the height, which was given in the diagram. So that's the volume then. So we're going to work this out, multiply it all out, and hopefully we should get this. So I'm going to do the first 2 brackets. 12 by 12 is 144. So I can see, maybe that's going to help me here, 144. Then I've got minus 2h by 12 is minus 24h. The 12 by the minus 2h again is another minus 24h. And finally, minus 2h by minus 2h is plus 4h squared. Plus 4h squared. So there we go, that's that bit done, but I still have the h there on the outside. This h, I haven't dealt with that yet. So that's the last thing to do, is multiply this h by each term inside the bracket. So the h gets multiplied by each of these. So h times 144 is 144h. h by minus 24h is minus 24h squared. And again by minus 24h is another minus 24h squared. And then finally h by 4h squared is 4h cubed. Okay, so we're nearly there. All I can do left to do now is I just combine these two middle terms because they're both h squared. So I get 4h cubed, I'm going to put that first now. 4h cubed minus 48h squared, which is these two terms, and then the plus 144h at the end, which is what we got up here, what we were asked to show. So that's the volume of the box in terms of h. Part D says, find the value of h which gives the maximum volume of the box. Okay, now what we can do here is we can use, if I just write the volume of the box again, which is 4h cubed minus 48h squared plus 144h. So this is a function, or it can be thought of as a function where v is expressed in terms of h. So if you want to find the maximum volume of the box, so when is v at its maximum, what you can do here is differentiate. In other words, you can find dv dh and let it equal to 0, and that will give you the maximum volume. So we differentiate this, and we can use this rule from the tables book. I've taken this from the tables book. If you have a function x to the n, the derivative of the function, we can use this rule. So for each term we can use that rule. So we bring the power to the front, that gives us 3 times 4, which is 12, and then reduce the power of h by 1. Do the same here, bring the 2 to the front, multiply by minus 48, that's minus 96, and that's h to the power of 1. 2 reduces to 1, so or just h. And then finally, if this was a 1, bring that 1 to the front, multiply it by 144, which is still 144, and the h, the power 1 gets reduced to 0, but h to the 0 is just 1. So this just stays as 144. So that's dv dh now, the derivative of v with respect to h. And what we're going to do then is let that be equal to 0. So we can let that equal 0 to find the maximum. Let the derivative equal, sorry, that's 12h squared minus 96h plus 144. Let that equal to 0 and solve. Okay, so this is a quadratic equation. So I'm just going to use the quadratic formula, which I've also taken from the tables book here. So my a values will be the number in front of h squared, which is 12. My b value will be the coefficient of h, the number in front of h, and the c value will be the constant at the end. So that gives me h then is going to be equal to minus b, which is minus 96, plus or minus the square root of b squared minus 4 times a times c. So just replacing all the letters with brackets and filling them in. So b was minus 96, a was 12, and c was 144, and underneath a again, which was 12. So I'm going to do this on my calculator now, once with the plus and once with the minus, and I'm going to get two different answers. So when you do that in your calculator, you get two answers. H is equal to 2 and h is equal to 6. So they're the two answers that you get. Now it says find the value of h which gives the maximum volume of the box. Okay, now if h was 2 and h was 6, if you go back to the original diagram, which was here, if h was 2, that would mean that this would be 2, this would be 2, and the length would be 8, because 2, 8, and 2 gives 12. And if h was 6, and this h was 6, that means there would be no length, because 6 and 6 is 12. So the 6 value can be disregarded. you can disregard this value. So the answer then is h is equal to 2. So you need to check the values with the real life situation. So the value of h is 2. And finally, part E says find the maximum volume of the box. Okay, so we know h now is 2, so what's the maximum value of the box? Well, we can see here that the volume is the length by the width by the height. And if h is 2, that's going to be, here you're going to have 2 for the height, that leaves 8 in here for the length and the width. So the volume would be 8 times 8 times 2. That's the length by the width by the height. Length by width by height. And that gives us an answer of 128, and it's centimeters cubed for volume. So the other way you could do this, find the volume, is substitute the 2 value in here to this function here. Just substitute 2 in for h and work it out. And that would also give you the same answer. So that's the end of part E and the end of question 8.